I'm gonna give you the little star, Steven, and let you roll with it.
What's the star mean? Oh no.
The
I'm the
facilitator.
facilitator. Okay.
Yeah.
Sounds good.
Have y'all seen our friend before? Do y'all know him?
Alexi, have you been to these before?
Hey there. Nope. First time here.
Great to meet you.
Yeah, great to meet you.
Feel free to put anything on the agenda if you want to chat about it.
Yeah, sure.
Just one thing. Yeah.
Cool. Awesome. All right. Maybe we should get started. So first thing is issues with multiple build plan entries and or. Oh yeah. I saw that on Wednesday. What's up?
Yeah, I could is find an RFC for it, but I assume this was an edition where originally there was just one build plan and then it was added so that there could be multiple ones. And I'm assuming the decision for OR was to not break backwards compatibility.
It was definitely to not break backwards compatibility in that we didn't add a new top level list. So things that are still written to the top level don't have to be nested under the OR. So you're allowed to have top level entries, and then there's a special entry called OR that's now a list of objects that's additional alternate build plans. But if you don't have a top level entry, you can just put everything in OR. You can even just have one thing in OR, and I think it'll still work.
Okay, so that's what this issue may be very specific because I was writing like a binding for the API, and I noticed that most bindings just ask for a list of build plans and then they convert it to the structure where they take the first build plan out, they put it in the top level one, and then they convert the others to this list of OR entries. And as a Buildpack author reading this, it feels like the first build plan is special in some way and the others are not. And it also sort of is a weird disconnect between your API bindings, which are just a list of build plans, whereas when you check the spec or something, it's now converted to this like one top level object and a list of things under OR. It's just a nitpick. I found it weird when I was first writing that. I was just hoping for some thoughts from other people, like what was the original reasoning for this decision, and if people are like what people's thoughts would be on changing it to be one uniform build plan object list.
I think you don't have to use if I remember, and the implementation could have changed, but originally you didn't have to use that one top level one. You could just use OR as a thing, but we still support not using OR and using the top level in addition. If that's not true, it should be true. and I think we should put an issue about that because it definitely feels wrong if you have an automated series of alternative build plans and you have to extract the first one and do something special with it. I agree that that's pretty crazy.
And shouldn't we deprecate the top level one if it's just like I don't get what's the use of the top level one then?
I think most build packs don't use OR. OR was added after build plan API had already been developed. And it was based on feedback that sometimes an example is you might want a build pack that provides either JDK or just JVM. And you couldn't say it provides both, and you couldn't say it provides neither because the build plan is it doesn't give you that much power. And the answer to that was you should just have separate build packs for the JVM and JDK because it would work as expected. But then we got a lot of feedback that it was too much overhead. I think Ben was a big fan of or felt like it was really necessary because he developed Java build packs that needed to use this in some contexts. And so we tacked on this okay, there's a special top level key that's a list of objects called OR, and you can put alternative build plans, and they'll be treated as alternative build packs, just as if you put the build packs vertically in the build plan, but they'll run the same build pack code in the end. So when you're parsing OR, think of it like it's like a way to do a vertical, if that makes sense, in the 2x2, but just all within one build pack, a bunch of different alternative things. And so the whole group is evaluated. The first one, it's actually a little dynamic programming algorithm I wrote in there that does fast resolution of the, the thing on top of ORs. And so that was the motivation for it. I agree, it's a little ugly, but I don't know if we'd want to break the API. And you can just ignore the top level one, I'm pretty sure. Or if you can't file an issue, we should take care of it. Someone should take care of it.
Yeah, that was it. So I guess I'll just use the OR thing if I have multiple plans, and if not, I'll just switch to just the one single entry. Okay.
Definitely. And let me know if it doesn't work. You can also just do one entry in OR too. You really, if you wanted to just pretend like OR is all there is, I think you can do that. If that makes sense. But if you feel like it should change, definitely open an RFC. Or like, my opinion isn't I only get one vote. Cool. Any other thoughts on OR? Sorry, I didn't mean to take up that conversation. Cool. Unintended build pack layer modification issues.
Yeah, this is this random thing I've been facing where if you provide a build layer and for some reason the future build packs run some executable which creates some random like modifications to the original build layer, even though like they're not really needed. For example, you run Python or something and that creates some random cache objects. Now that invalidates the original layer, even though there were no modifications to it. Invalidates it in the sense that I have to push a whole new layer out to the registry. And those layers and pushing them out and pulling them in can be like really expensive when nothing really has changed apart from like these random files. And I've tried a lot to get like by these issues by like disabling some random specific settings, but the problem is there's no way to make a build layer read only by future build packs. If it was read only, those entries would have never been written and this would have worked as intended. Like typically you have some system executables which are on some protected paths and you can run them and you can execute them, you can read them, but you can't write back. So that works. But in this case, since there's only an option of like build as a Boolean, true or false, any future build packs can then unintentionally modify previous layers, which seems weird to me.
Is this for a build equals true, launch equals true layer you're thinking about? Because it's a layer that needs to go to the registry, but also needs to get exported to other build packs. And the inefficiency is when a later build pack, then it's not that a later build pack could do this. It's actually when a later build pack writes into that layer, it then invalidates it. And yeah, so the API says that those are contractually read-only.
But I can't control it, right? So if I'm using it's like I'm using, let's say, for example, Python or GCC provided by one build pack in the future build pack, I can't control the modifications happening there. Like I had to do a lot of deep dive, do a lot of cleaning at the end to make sure those things were not happening. But it shouldn't, I guess it's also an issue with certain like executables which are creating these random files in the same layers directory. But I would imagine that others may be facing this and they may not even be knowing about this, because technically your cache is not invalidated. You're just pushing a new thing out to the registry, which is, I guess, inefficient, but that's about it. I don't know what.
So if the contract says that they're read-only, right, could there just not be additional checksums made on the layers throughout the different build pack executions that when they don't match up, it just basically fails, or at least warns to let you know that something
That
has changed.
Yeah, because it wasn't even easy to investigate this whole thing, like what was actually causing the layer digest to like change. So I had to do an individual file diff for all of the layers and figure out which build pack was actually responsible for making these modifications, and then correct all of the future build packs so that they don't modify the original layer, which was, I don't know. I think that checksum thing would really help, so that if some future build pack is modifying like a previous one, it wants saying that, hey, this build pack modified this previous one. So at least I know, okay, this is the build
The
pack.
one that's causing the issue,
Yeah,
right?
yeah.
Yeah.
Because even that was difficult to figure out right now.
I see a couple other options too. One is we could create the layers, like create the layer TGZs iteratively, like during the build pack process instead of all at the end during export. And that way, if another build pack layer does make a change to it, it doesn't actually end up in the image, which may be that may be worse, right? It may be better to prevent that from happening or throw some error. But then we don't have to calculate a checksum in the middle and then store that checksum and then make sure that, or and we're not calculating a checksum of all the bits twice if we didn't want to also compress it during the initial step. It seems like the implementation would be a little harder, or it would hurt performance, right? To take iterative checksums of everything and then also checksum at the end in order to export. So that'd be an option I could think of to consider. The other option is we could make everything root owned kind of as we go along, right? So the builder could, we could say the builder runs as root, which I don't like. I kind of don't think we should do that. And it could, after each build pack execution, switch the permissions from the build time user to root, right? Progressively. We've kind of talked about how it's, we definitely should have a different build time and runtime user, right? And that's already kind of supported. But maybe, the build time user could be a temporary thing, kind of.
I don't think I'm a fan of the latter idea, because I definitely don't want the owner of the layers that I've created to change. Randomly. So what would happen in that case when a layer is marked as both build and launch?
It'd be fine, right? The layer would become root owned after the build pack execution. It'd get uploaded into the image and it'd be owned as root in the image, and then the other build packs wouldn't be able to write to it, assuming UMask 022.
Yeah. I'm not sure about that part, because I guess it's also sidestepping the fact that currently you have technically three users. One is like whatever was the user that created things in the stack. One is your build user and one is your runtime user. And I mean, there are a lot of cases where you need more than just root and a non-root user. And I definitely wouldn't want to trade the fact that there is a separate build user with fewer permissions than root that owns these files.
We'd also have to be really careful about set UID and set GID type things, right? As soon as you're changing something that a regular user wrote to be owned by root, it could introduce security vulnerability to that. So I don't love that solution either. I just wanted to throw it out there as like, that would also solve the problem, but without having to deal with, with nothing computational at least.
Because I think I technically also have use cases where I do want the other thing as well, where I want future build packs to modify it. Like if I set an environment variable in a specific build pack for the future build packs, and they expect that thing to be writable.
Spec violation.
I thought we mentioned, like we discussed this last time, and like the idea was that if a build pack exports, like here's an environment variable that holds a folder, and it's marked as that thing is marked as a build layer, why should the future build packs care, like what's wrong with future build packs modifying that?
Then
Where the intention of that build pack is so that others can write into it.
I think how that intent is communicated would be very important, because oftentimes a build, so like we set environment variables like path, right, that point into bin directories of previous build packs automatically. And in that case, the contract is definitely, you're not supposed to write to this. This build pack took a checksum, right? By default, we do that for the kind of standard POSIX environment variables. But if there are other environment variables that are varying degrees of standard, right, that point back to directories, what communicates that it's okay to write back into that other directory? It seems like it's always going to be risky, because there's this process of storing metadata about the layer in the registry and then recovering it and comparing it, that, a build, if another build pack could write into that build pack's layers, its metadata would suddenly not match its bits. And then, it would increase complexity a lot, right? We'd have to have some kind of management system for ensuring that the build pack intended it for it to be writable.
A launch layer, right? If I'm talking just about build and cache layers, which are modifiable by future build packs, that should still be fine, right?
Unless the build pack expects to get the build equals true, build equals, or cache equals true layer back on the next build the same as it was before, right? Maybe it's like using a build layer and then moving stuff off to a launch layer. It seems like it can make cache management pretty difficult. You could add a write equals true.
That's what I was thinking of proposing. Like if you have build write equals true, or like your build flag instead of a true or false is like false, read, or write, in which case read just exports it out immediately and write just makes it available for future writes as well. I imagine that would be useful. At least to me, I don't know about other people on the call, like if they have had a use case like this.
If we did the middle option, right, of exporting the layers in the middle, right, between each build pack, move that responsibility of creating the layers out of the exporter into the builder, right? And then when it sees write equals true, it actually just means defer creating the layer until the end of the whole build process, right? Then we can do it without any performance hit. It would guarantee that only write equals true layers, actually end up getting exported with writes. And then it would, guarantee. So, but it does have the problem of like, it means the changes are allowed and then blown away at the end, as opposed to, but it would be efficient. But that doesn't seem too terrible to me. But that would be a way to implement that write functionality.
Yeah. Cool. I'll see if I can propose that.
Yeah, it'd be really interesting. It would definitely open a new kind of new set of functionality in shared caching. I do wonder if like those kind of shared caches could just be temp directories, unless they need to get recovered. That's an easy way to set an environment variable that points to a temp directory that things share, right?
That's sort of the use case where I want to recover it because it's a build cache there. So
makes sense. Got it. Definitely open an RFC. That sounds very interesting. Anything else on write caching and all that? Javier, did you feel like you prefer if we take the checksums? I'm curious if we take checksums of the things along the way.
I think both of those seem very reasonable, right? I think they just become implementation details, not something that would be part of the spec, right? So ultimately it becomes to what becomes the most optimal way of doing it.
Yeah, makes sense. Performance seems to be a big issue now. Or like people
Yeah,
are very
exactly.
interested in
Yeah. I just go back to the good old checksums, but yeah, you're right.
All right. Next on the list is the state of the build kit integration from Alexi. Is that how you pronounce your name? I'm sorry.
Yeah, Alexei, once again. I'm working for a small company and we are looking for a way to adapt Buildpacks. And currently we use BuildKit. And I think I found this issue. I want to understand what is the current state of it, and it might be that you have some estimations, planned work, or maybe deadlines for it.
I think Javier was looking into that, right?
I could speak to a little bit. I'll throw whatever I can out there, and then Stephen, if you have any input, you also can.
Mostly
Um,
questions. Sorry.
What?
I said mostly questions is what we
Right,
have,
right.
but yeah.
I guess first of all, I want to start off by saying that this is something that made it onto the roadmap for the project, right? So it is something that has a little bit, maybe not in a direct way, but us trying to get like that Docker integration story a little bit better suited is a reason why we're pursuing this quite heavily. That being said, the thing that you linked to the issue, there's an individual from Bloomberg, Eric, who kind of created this proof of concept, and he's kind of like been iterating on it. We got some really good insight from that POC, and ultimately what it looks like is that it's fairly achievable within a reasonable time frame. The only drawback is that it does require some changes to the lifecycle, which is kind of like the engine, right, that runs all the build packs underneath. So it would require some changes there in order to be able to properly, I guess, integrate the exporting, right? Like how we are able to take the outcomes of the build packs that go into the registry and instead put them into the build kit engine or system. So that's kind of where we're at right now. So if we kind of dive a little deeper, right? I think where I'm personally with this is I talked to Emily about kind of how we would do that build kit and lifecycle integration, how we could make that actually work. And we landed on supporting OCI layout as an exported output that then we could read through the build kit to, again, put it back in there through the build kit front end to put it back into the build kit system. So that's going to be like an RFC process, and that would require essentially a spec change to finally get done. But it's still top of mind. It's just hard to estimate exactly how that all would work out.
Another thing to point out is that there's one aspect of our current caching model where, especially if you're not doing a local build, if you're doing a build against a registry, some layers don't have to get regenerated locally at all or be present locally at all to, recreate the final image if they're already in the previous image. And that requires a bit of a part of build kit that hasn't been implemented yet. There's like a merge op they have an issue for upstream. So some of the efficiency of when you're building, especially when you're publishing directly to a registry, probably will only work in the old lifecycle model.
Sounds like a huge amount of work, guys, especially specs part, right?
Yeah, I definitely would.
Works. Sorry.
Yeah, I was gonna say, like, I think it's definitely not like a very short-term thing, right? But I would definitely say that it has traction and there's a reasonable amount of effort behind it. I am curious how you would envision this to I guess help or how you would use this within Shippa, was it? Is that the?
Yeah, we have a kind of building pipeline, and we build images from source code, and we use another approach right now, and Buildpacks are very suitable for us. That's why we are looking for this issue. Not sure that we have much resources to contribute it, and that was the goal, to understand. Are you working on it, or you are looking for community to contribute?
That makes sense.
I think it's important to note that you don't need pack to do a build pack build or a Docker daemon at all right now. The lifecycle by itself, when run in a container, on any container coming from anywhere, it could be on K8s, could be a local Docker daemon in the case of pack, right? But it could be in a GitHub action. Anything that can give you a container can do a build pack build entirely in user space with no namespaces and generate an image and export it to a registry. So our kind of security model and number of dependencies is actually lower than build kit, which requires some special capabilities. Like I think it still needs user namespacing and things like that. So if the reason you're looking for BuildKit is that you want to be able to avoid the old Docker daemon, you can avoid that today. Actually, you don't need it's only the pack CLI interface that uses the Docker daemon, and that's not using Docker build underneath. That's just using running Docker containers in order to get a containerized environment. I don't know if that's helpful.
Okay, thank you, guys.
Cool.
Yeah, just to add to that tidbit, if you are curious on how this would look like, we do have like the Tecton integration where it works more with, like almost direct execution of the life cycle, which again is like the engine. And you could kind of see how that's structured or architected. So again, you can kind of build anything around it, right? The reason why we're pursuing BuildKit is more so that we could have it in front of the end user that already has the Docker CLI installed, right? Not so much because we need it to enable additional capabilities or anything like that.
It's really a local desktop feature.
I think that's what Steven just added as on the chat.
All right, anything else about BuildKit?
I did reach out to Eric. We're kind of discussing the potential of coming to one of these office hours to kind of give a presentation of, what he's been working on, his discoveries, and, some of the challenges and stuff like that. So hopefully we're able to schedule that here soon and we could get yet again more traction on it and more discussions around it.
That would be nice.
Awesome. Next thing on the list is a peculiar case of detect and build from Sam.
This is so let me try and like give some background. So let's say you have a build pack which provides a generic package manager like apt or yum, but that works on non-root stuff. So you're using that as a way to install like dependencies, like typical system dependencies, and you're using future build packs to sort of encapsulate specific things. For example, um, you have specific package names for Python 3.7, Python 3.8, etc. Whereas your Python build pack just wants to provide like Python and have the metadata contain the version which future build packs can request. Now, the sort of issue I'm facing is that this particular Python build pack has to request um, the original package manager that I want this list of packages. And those list of packages depend on the version which is determined by the, let's say, future build packs. So let's say a future build pack tries to read some other random files and get back to the Python build pack and say, hey, I want Python 3.8. And during the build process for this Python build pack, it's not doing much. It's just like, hey, during the detect process, it figures out that it requests these packages from the original package manager build pack and pretty much just provides a small encapsulation that it has the knowledge of which all packages to request. So like Python 3.7 could consist of like 5 or 6 different packages, and I don't want to duplicate that logic each time in future build packs that are actually requesting the specific version. Now the issue is since detect runs like once as a whole, there's no resolution process that happens before build. And by the time it's gotten to the build for this Python specific build pack, the package manager has already done its entire processing. So it can't re-request the packages it wants. So the issue is that the resolution is currently coupled with build, which means that if you have a case like this, which I don't know if a lot of people will have, there's no real way of sort of does the thing make sense?
I have a bunch of questions. I'm not sure if I understood completely. I thought you said packages like apt packages, like you're talking about operating system packages. Is that right? Or are you talking about Python packages?
No, operating system packages.
Okay, so like two things. One, to answer your question directly, but without expressing some concerns first. The way this usually, I think the way people usually solve this is because the detection API lets you send information backwards. So a require can contain like version information in the build plan, and that version information gets sent to Buildpacks that said they were going to provide that. So if you're providing Buildpacks says, I need a package list or something like that, right? Like just a key. The build pack later can say package list and then provide information about the individual dependency. All of those will get collected for all the build packs that say they require that name. And that way, just during the detection process in parallel, so it'll be really fast, right? You can have all the build packs figure out what things they need from that package management, build pack. And that information during build will be available to the package management build pack when it does the installation. And so it's kind of intentionally, that's why the build plan API is a little much, if that makes sense. It's because it moves backwards and then forwards.
The issue is that the Python build pack is the one with the knowledge of the original package manager. And it is providing an encapsulation for the future build packs. The future build packs don't know about the package manager. They're just expecting Python with version X. So now if the future build packs request Python 3.8, I can't modify the package list from my Python build pack to the package manager build pack to include these new set of packages. Does that make sense? So let's take a simple example. You have an apt build pack, so that provides apt packages. Your Python build pack requests Python 3.7, Python 3.7 pip, Python 3.7 virtual environment, Python 3.7 dev. So there are 4 packages that it is requesting. And your future build pack that uses Python says that I just want Python with version 3.7. That's it.
Okay.
Or Python with version 3.8 or whatever.
Let me restate. 3 build packs. First build pack is app build pack. Second build pack is Python build pack. Python build pack depends on some packages, some operating system packages that are going to get installed by the app build pack. And then you have a third build pack that then depends on Python, right? And in the build plan, you would see app build pack provides some things. Python build pack requires operating system packages. Third build pack requires Python. Did I get that right?
Yeah.
Cool.
Now, the issue is that the operating system packages that I want depend on the final build pack. So like if the final build pack says I want Python 3.8, then I have to change the operating system packages I require from my Python build pack. Now, the name of the dependency is the same, like it's Python. The only thing that's changing is the metadata. So even if I use the alternative build plans,
Yes, I was just thinking.
So now does that make sense? The issue make sense?
I think so. Could you? I want to talk about other concerns with the operating system package thing, but I'll put that to the side for a second. Okay, so could you have different different alternative Python names that reflect the different kinds of like version or package information? Sorry.
I could do that, and that was the alternative answer I came to, but that seems a bit weird to me because then I have to sort of list out all the possible versions and also make sure that my future packages know the the version string, like any metadata, any extra metadata, I have to concatenate that to my like provision name, which seems weird to me.
Patch version of Python doesn't matter though, right? You're just talking about all the minor lines.
Sorry.
The patch version of Python wouldn't really matter in that case though.
Okay.
It'd just be all the minor lines, right? And they're only like, there are a fixed number of those, but
Yes,
it's not great.
This was an example,
Okay.
that's the simplest example I could think of, but you can imagine the same case happening with other thing, which like encapsulate the system packages that they resolve, and some future build pack just assumes that, hey, I have Python, I have Go, and that's all I require with this version. And then you have this intermediate binary provider that's like plugging in requests from the system package manager to these individual configuration build packs that require the specific binary.
Yeah, before we try to solution that, I want to ask about the operating system package installation build pack. So if you have a build pack, people have made build packs like this in the past that are like it's like an apt build pack that downloads app packages from Canonical or wherever, right? And writes the packages into build pack style layers. That only works for like a very small subset of packages that don't have any hard-coded paths in their binaries. And it can actually lead to some pretty nasty security issues if like, because it'll look for a file that's important that has some configuration in it that's missing now in the file system. So I think this problem still happens with stack packs, which will solve this. Like stack packs let us introduce an apt build pack that installs app packages into the base image, right? And then subsequent build packs will need to depend on mixins that get installed by the stack pack. And then if another build pack depends on that build pack, this build pack can't adjust the mixins it needs to install. So I think we still have the same issue with stack packs, but I just wanted you to be aware that it's usually a bad idea to use a build pack that installs operating system packages into layers. So we should use stack packs for that.
Yeah, this package manager is not apt or those typical things. It's specifically built for this purpose. So
okay, cool, got it, perfect. Like Nix or something. Yeah.
This was the closest. Like I just wanted to give an example. That's why apt and Python.
Yeah.
So I guess that's an issue. And my question was sort of like also what you were getting to, which is how would stack packs solve this? Like, is there a resolve process in the middle that would figure this out? Because I imagine you would have the same problem once you get there. And I would imagine this would be a very common use case where you have one thing that encapsulates all your dependencies, because then like you have like these whole slew of config only build packs, right? That only care about Ruby being present or Go being present or Python being present. They don't care about where it's being fetched from. And now they have to know that, okay, I require this from the package manager instead of just depending on a Python dependency with this version or a Go dependency with this version. So you're breaking this like nice modularity you have. And I don't see a nice way of solving it apart from that one solution you mentioned about just appending all the metadata to the list of to like.
You could make provides have a conditional require. So if a provide if a provide is met, right? Like you could somehow put information in the build plan. Like say if a provide is met and it's met by require. Right now, provide just has one name in it, right? So this is like an idea for an RFC. Instead of putting metadata in the provide, because that doesn't make sense, the metadata comes from the require, you could have like matching strings against the subsequent metadata that then imply additional requires. And that way we could handle it all during the detect phase declaratively and in parallel without introducing another resolution step. You can make the provides match strings coming from the requires, and then the result of a match could be additional requires that the build pack that get added to that build pack's list of requires. Does that make sense? I think that would solve the problem.
Can you give an example in this?
Yeah. Okay. Sure. So apt build pack first, right? We'll use your example. Apt Python something that needs Python, right? I mean, this is an RFC. This is functionality that doesn't exist, right? Have the Python build pack in it has something that says provide Python, right? Right now that provide only has one key allowed name, right? Let's add another key, filters, right? Under its provide Python, right? In filters, it's a map of things like, maybe it's a map of, well, some data structure where it would match something like version equals 3.7 star,
Yeah.
right? And then, and the additional fields requires under there, and then, libvert, muscle, I don't know, whatever, making up C library names. And then in the case that provide matches the requires other metadata, it would imply additional requires on the earlier stage. Yeah,
Right.
there you go.
That makes sense. Yeah, that would solve this use case.
I don't know if we should do it, but
I guess it will also make this whole, like, I imagine, like, it would also make explaining build plans to like newcomers extremely extremely cumbersome. Like, why do you have this additional thing? But yeah, that would solve the use case.
I've always thought that, there's something about provide being a little too, like, it's only one name. Like, why do you have a list of names here? And there's this metadata that gets sent back. Should we do version matching? Like, should detection say, this is a Python 3 build pack, and this is a Python 2 build pack. So, this will get that, this will get the other thing. And I always come back to, like, well, in the end, if that's the case, then the name should be Python 2 or 3. But this is actually a use case where we could really drive out some more structure there. I don't know if it's a good idea. At least it would be like kind of progressively complex, right? You wouldn't have to deal with it until you had this really weird use case, kind of like OR, right? No one knows that OR exists until they need to solve the problem. So it doesn't bother me too much if you really felt like it's something you need. I wouldn't stand in the way, although I agree, like,
yeah, this is, yeah. That makes sense. I'll see if I can write this up. It would be really useful, and I guess this would come up more often once we have stack packs and you have other like use cases where people like Buildpacks can actually request system packages, because then this would become really common.
Yeah, makes sense. It'd be great if somebody invented a like kind of staged based dependency management system that we didn't have to invent a new one ourselves over here, right? Like, we did a lot of research into, like, the existing package management systems provide some kind of functionality we could use here. And in the end, the problem is we wanted Buildpacks to be swappable, right? And run sequentially, like they're build stages. They're not like things that depend on each other. And so package management, we couldn't make a solution there work with an existing thing. But it'd be really nice if somebody had invented something sane ahead of time, so we didn't have to try to kind of organically build our own system.
So the other question I had was, is there a way to pass state from one build pack to another apart from provisions and requirements? Or is that the only way of communication between build packs during the detect stage?
During detect, that's the only way. During build, you can push stuff forward, obviously, with layers, but yeah, detect always goes in reverse. Build packs always communicate backwards, and then build packs always communicate forwards, and at least that keeps the data flow simple, right? If that makes sense.
Because this was like, I mean, this is one use case I've imagined. I've not used it, but if I've seen it in Pacato in a couple of places where it's used slightly differently, but you sort of have these converter build packs in the middle. So let me give you an example. I tend to fall back to Python because I'm most familiar with it. But let's say you have a Python build pack that looks at requirements.txt. and installs those packages. And now you are using some alternative like dependency uh, like specification, like you're using some other package manager which uses some lock file like poetry lock or pip file or whatever, that can then be converted to this requirements.txt stuff.
Yeah.
So now you want to maybe modify the app door so that this future build pack, which has no idea that this exists, can still detect and run as intended. Uh, but it's sort of focusing on build packs that don't know about this other ecosystem or whether it exists, and they have limited their way of asking for provisions or requirements just to like specific files, or they only support a specific API, and you want to write converters between one API to this popular build pack that supports a specific API. Now, in that use cases, I've not found like a way to make this build pack detect, like even get past the detect state, so that during the build stage it then picks up these things. So is that use case like is that clear, like what I described?
All right, I'm going to try to say this back to you again. So you're talking about the case. This is like a common case in Python. I vaguely remember from working on Potato a little bit, where you have your app directory. It's like a poetry app, or I think at the time it was a pip file, whatever it is, pip file, I think, app, and it's useful to convert the pip file lock, whatever it is, into a requirements text in Python's original format, in order to process it with the normal, standard Python tooling, because other tools use that as like a whole Conda ecosystem that's different, and I'll put that to the side for a second. But the you're generating that requirements file, and then at the end there's a build pack that does whatever it is, pip install in the requirements text. Okay, I get that. So you have this intermediate build pack that does the transformation. From there, what's the issue with? Start from there.
My issue is that pip build pack only passes the detect.
Stop. Which is the pip build pack? Is that the pip install build pack at the end?
Pip with requirements, so like pip install requirements build pack.
Last build pack.
Yes.
Yeah. Okay.
Now that only passes the detect stage if it finds a requirements.txt.
Only passes the detect stage. Okay, I get it. In the app directory when it doesn't exist yet. Perfect.
And now you have these alternative formats, which are obviously not requirements.txt, which you would convert to requirements.txt in the build stage. And now you want your pip build pack to pass so that during the build stage it can run this step.
Okay. Stopping there for a second. So if the pip build pack, that last pip build pack shouldn't look in the app directory for requirements. It should output a build plan that requires requirements and make itself optional, right? And so another build pack can say it provides the build plan, right?
Yeah,
Isn't that usually the solution?
That's a solution. So that's, I think, how Paketo implemented it. Like they removed the detection just from requirements.txt and added like a optional build pack that always passes, and added a provision which has to be satisfied by future build packs so that it can be included. But that's again pretty complicated for someone new to understand. That you have to now add like a build pack that always passes, but with only a provides. And then because the whole detect stage runs a set of build packs and the provisions have to match requirements exactly, only then this build pack would be selected. That was something that took a lot of time for me to explain to other people, that, okay, this is why it works, and this is why you have to always make it pass with optional and with the provision, so that future build packs can then require this and then like.
Okay. So could we make a special field and a require that that says that this require optionally, instead of, it can not only be satisfied by a provide of requirements text, but it could also be satisfied by this file in the app directory existing or something like that.
Yeah. I mean, these are all edge cases which I think I've had a really tough time explaining to people, or when I've tried to explain the whole detect and build phase to them. So like it's easy once you understand the whole process, but for someone new to,
Yeah.
it's easy for them to like tell them, okay, the detect is a series of transformations and this detect works in isolation. So if it finds that file, it will pass. And in order to find this file, I can just have a build pack in front of it that converts from file X to file Y so that this other build pack passes.
Like on separate things, right? Like if we have edge cases in the build plan that make it hard to use, we should figure out how to fix them in elegant ways that don't make it too complicated if we can. So like really interested in RFCs about that. But we also have talked about like, Terrence and I have especially talked about this. It's like really, the build plan solves a particular problem that's, kind of designed to allow this modularity in the API, right? It has like, the goal is good, but it definitely is like, you can kind of ignore it if you're just making a build pack that needs to do something in the middle. But if you really want to integrate into this kind of modular ecosystem, there's a big learning curve there that we haven't figured out how to explain. And I don't know if the answer is like, we need a really good page on Buildpacks.io that's like build plan, and it really has a bunch of images and, shows the data flow model, and you just get it after you see that for 5 seconds or whatever. Or if there's, some way we can simplify it. Some if there's like complexity in here that doesn't really need to be there.
Because so whatever I explain, like doing this when I'm writing code, like I had like huge doc strings explaining why this particular build pack always passes.
Yeah, that makes sense.
Which like for someone who's like new to this, it takes them quite a while to understand this specific use case in order to make build packs modular.
The original build plan was worse. So there was the first build plan proposal. It would like, instead of all the things running in parallel and then doing resolution, it would pipe data between them, and so they could, it was a much more complicated thing. Sorry.
Yeah, sorry.
No worries. The original build plan would actually set up pipes between all the build packs, and they'd all run in parallel, but they could read standard in to pull information. And then it was this very, it was like kind of a white box. And then that requires provides things started happening, where later build packs would say, I need something from earlier ones. And so the current build plan model is a simplification of a much more abstract thing that kind of landed originally. It's like definitely evolved a lot over time, or like there've been breaking changes to it in the past. If there are ways we can improve it to make it easier for users, like really interested, like it's not something that, we said, this is the perfect way of solving this problem. And, went with that. It's more like, it's really been a long process of making changes to it over time. So if you have ideas, right, like really interested to hear.
The easiest idea I can think of would break the fact that you can run build packs in parallel.
What would that be?
Like you make the app directory writable during the detect phase and run build pack sequentially. That would break the parallel detection thing. I may possibly slow down things and encourage build packs to do build steps during detection. Not ideal, but that's like one easy way to get out of this. Like, I mean, they would only be able to modify the app directory, but that's still like a lot of freedom during the detect phase.
Yeah. So that there was actually, I was talking about how it used to look different. So before they ran in parallel, but they all they could output to standard out, and subsequent build packs could see that, and build packs could read from standard in. And so they'd all run in parallel, but you could kind of block on the build pack before you, if that makes sense. So you could read from standard in and then wait until standard in closed if you needed to get information forward during build, during detect. But that got like, that was like more complex, because then you have this, like you have to know about how the, whether standard in is open or closed, and you're, also passing all the data forward meant that it had to either accumulate. If you put a build pack in the middle, it was much harder. So this this kind of declarative model where they can't talk to each other, and then there's a resolution step, I thought was a nice simplification. But like, you're right, you can't pass stuff forward, and so you have like your requirements text issue, right?
Yeah. So actually the model that you're talking about, where you can pass data forward, would also fix the stack pack issue if you move this random third build pack between the package manager and Python, where it can request Python version 3x. And then the Python build pack can read, okay, it's requesting 3x, so that I can now request these packages from the original package manager. So that would solve this. It's because this third build pack has to come at the end that we have to think about these conditional requirements. But if it could come before it, then that would also, I guess, would be simpler and solve this.
We could keep the current model intact and then just introduce a forwards communication mechanism and then break the parallel thing, right? Or even, introduce some named pipes, and you can read from the named pipes if you need information about past build packs, right? And then introduce, and we could keep the parallel thing, right? But I worry about complexity there too, right?
How
Sorry,
important was the parallelization step? Like, how important was it to have detection in parallel?
It was done in parallel because switching to the declarative model meant that the build packs no longer depended on any failure, and so we could get that performance benefit. And also because sometimes, like, if you're using the Pacato builder and it lists 10 different language ecosystems, and each of those you expand out into this 100 row grid, right? And if the build pack you're selecting is near the bottom of that, then it's a long time to wait for all those processes to execute, individually. So it does save a little bit of time, right? The rows themselves don't execute in parallel, only the build packs across here, right? So there is a bit of a performance benefit to it, but it's not huge, right? So that's, we can do some testing, to take out the multi-threading there. I really got to drop to another meeting. This is great though.
Yeah.
Please open RFCs and.
I mean, if I
thanks.
can think of some solutions, I would, yes.
Sorry?
If I can think of some solutions, I would. I think I'll start with a discussion, and then if we can consolidate on something, we can. Yeah,
That sounds great.
Yeah.
Thanks.